Hey guys, so we've learned 4 different strategies for how to divide fractions. In this lesson, you're going to use all 4. Are you ready? Get set. Here we go. Oh, and again. All right, so the first strategy that we learned was using a diagram, right? And that was when you would take a fraction and we'd find a way to use the diagram where we did it like on Seesaw. All right, so I'm going to start with this division problem, 3/5 divided by 1/4. And it's important to remember that that means how many 1/4 are there in 3/5. It's important to remember that I start with fifths because I have 3/5 and I'm trying to figure out how many 1/4 I can get out of it. So as you can see here, I have 3/5. Now I got to divide it into fourths horizontally. Now that I've divided it into fourths horizontally, I got to move some pieces around to figure out how many fourths I can actually fill up. All right, so I did some moving around. I moved some pieces up, but now I can see that I can get one whole fourth, another whole fourth, and how much of another fourth? Well, 2 out of 5 pieces, so I think I can get 2/5 of another fourth. Another way you could try to do this diagram is to try to draw 2 lines that are the same length. The first one broken into fifths and color in 3 of them, and then try to think about how many fourths could I get out. I could for sure take that one out, that one. That's the question mark, right? And that's where we can do some math to figure it out. All right, so the second way we learned was common denominators. Now remember, common denominators is a great strategy because it helps you get things to be the same size parts. So like over here, how many 1/4 can I get out of 3/5? We're still going to do that problem, but right now, fifths and fourths are different size parts. So how could I get them to be the same size parts? Common denominators. So I rewrote the problem right here and tried to get these to be the same size parts. The first thing that I thought of that they could both turn into would be 20ths. So since they can both be 20ths, that would be a times 4 here and a times 4 here, 12 20ths. I'd have to times the fourths by 5, both the numerator and denominator, so that would be 5. So after I rewrite it, I have this problem. I'm basically asking how many 5/20ths can I get out of 12/20ths? Suddenly that makes way more sense in my head because these are the same size pieces. So how many 5/20ths can I get out of 12/20ths? Let's check. Denominators you can divide straight across. I always do the bottom first because 20 divided by 20 would just be 1. Now whatever number I get for my answer will be right on top. 12 divided by 5, that's the same as just 12/5. So 12/5 over 1 is just the same as 12/5, which is the same as 5 going into 12, 2 wholes with 2/5 left over. Did we get the same answer as our diagram problem? 3. The supergiant one. So if I have this problem, 3/5 divided by 1/4, remember I can write it as a super fraction. Right? Now, what could I multiply that by inside of a supergiant 1 to get my denominator to be 1? Remember we learned last lesson about the reciprocal. If I go over here, that's going to get me 4 over 4, which is 1. So I'm using the reciprocal of 1/4, and if I use that here to make it a true supergiant 1, I also have to use it here. So at the top, I get 12/5. Very similar to the common denominator method. I get the 12/5 over 1, which is equal to 12/5, which is equal to 2 wholes and 2/5. Supergiant 1, getting the same answer every time. Or keep, change, flip. We call keep, change, flip, invert, and multiply. Keep, change, flip. So keep the first fraction the same. So we keep, change the division symbol to multiplication, and flip, multiply straight across, you get 12/5, which we already know is 2 and 2/5. The only reason I don't like kids always using keep, change, flip no matter what, even though it works every time, is because they don't understand why it works. I can understand why common denominators work. I can understand why the supergiant one works because I'm trying to get a number in the bottom. I can even understand diagrams, but sometimes kids just use keep, change, flip because it's the fastest, but they don't understand why it works. So those are the four strategies. Assignment is going to be to go to lesson 7.2.4 in the CPM book. Go to problem 772 and pick out one of either A, B, or C. Just pick out one of them. Pick out one, A, B, or C, and I want you to show the four strategies for that one problem. Yes, you have to draw a diagram. Yes, you have to do common denominators. Yes, you have to do supergiant one. And yes, you have to do keep, change, flip. Remember, your answer should be the same for all three. So show how to get the answer using all four strategies, but you only have to do it for one of them, A, B, or C. Show how to get the answer using all four strategies on paper. Then what? Then take a picture of the work that you did on paper, on poster board. I don't know what you're using, but take a picture of what you did and how you showed all four strategies and attach the picture or copy and paste it onto the Google Doc that is attached to this assignment. Once you've shown all four ways and shown me that you know how to do all four ways for the one of those problems, you're done. That's it. You're done.